Hello everybody and welcome back to another classic arcade repair. To pardon my voice, I got a bit of a head cold going on, so yeah, good stuff. Anti-aircraft. This is Atari's all TTL anti-aircraft from, I believe, 1975 or 6. 74 actually. So I was wrong. I had to spend some time today putting together this harness. I actually put the credit LED in as well. I got my coin and start. Power is AC input. And yeah, so I got the video hooked up here. So we'll go ahead and fire this thing up. Okay. We got a loud noise and it's got a vertical scroll going. And I had already turned this on earlier today, and I can't really get this thing to lock in. And you can see the bullet in the screen. Kind of going crazy. I guess that's as good as that's going to get. So you can lock it into place, but it shouldn't be that hard to lock that into place. Well, these, I can almost guarantee that these electrolytic caps right here are open. These guys. So those will have to be replaced. And other than that, I want to double check the sync lines, and I'll just kind of start from the beginning at the sync and yeah, go from there. Anyway, if I coin this thing up, press the coin, you can see the LED, credit LED comes on, and if I hit start, I just hit start and it's not really doing anything. So let me grab this. Ground that. Yeah, it's not responding to yeah, it's not firing. Yeah, it's not really doing anything. And when I hit start, credit doesn't go out. So yeah, this thing's not working. Okay, I need to print the schematic for this. And I think preliminarily I'm just going to kind of probe around on some stuff. Just some basic probing around and see if I find anything that looks goofy. Alright, I kind of just quickly went and probed the whole board. And I found a couple of things that piqued my interest that looked kind of weird. Number one, this thing starts scrolling again. And it would not surprise me in the least if it's video signal through a partially open cap. So I think the first thing I need to do is go ahead and replace these electrolytics on the board that are original. And then we'll test those. But I'll show you what I was looking at here that just kind of don't look right to me. I put red marks on just as a reminder to pay attention to this. This one is a 107 and the outputs are here and here and then here, but you look at that, and here. No, I don't like the way this one looks, so I put a mark on that. And then over here is a 74 that had been replaced, but as soon as I look at the outputs of it, Q is high and so is not Q. They're supposed to be inverse. So it may not be this chip that's bad, rather something making it look bad. It could be prior work. I don't know yet. So I put a mark on it. Just pay attention to that. But I'm going to go ahead now and replace all of the old electrolytics. Okay, got all of the electrolytics replaced. And these guys here. And this one. So they've all been replaced. And here are the old ones. We'll test those out. 5 microfarad, which I replaced with 4.7 by the way. But that one's open. Another 5 on its way to being open. $10 microfarad. No good. And if that was the video cap, that would cause that funkiness. That rolling vertical. Just a corrupted video signal. 10 microfarad. 8.6 microfarad. I guarantee you this one's high ESR. If they're low, normally when these things age, they drift high out of tolerance. And the ESR will still be good. They're just the capacitance gets out of tolerance. When the capacitance goes down towards being open, the ESR goes up. So let's check the ESR with the ESR meter. Yeah, I got that connected, and ESR is 15 ohms. And it's supposed to be, that's a 10 microfarad. It should be about 1.5 ohms, so it's 10 times. It's 10 times out of tolerance on ESR. That also would cause a problem with video. Another 10. Open. 5. 2.4 microfarads, so this one would be high on ESR. And here's another 5. And it's also low. This one is a 47 microfarad, and you can see this one reads 104. So it is over 100% out of tolerance. Right, is 100% would be 47. 100% of 47 is 47, so yeah, this is way out of tolerance. Okay, and this is a 100 microfarad. And I don't know if this is a Sprague cap, but yeah, it's right at 9. Well, it's right. That's a good cap, basically. And here's the second 100 microfarad, and it is very good. Okay, so it seems to be locked in better. And I adjusted the 5 volts. It's got one of these regulators, and I just adjusted the 5 volts down to about 4.95, 4.96, something like that. It was up about 5.15. Lower that down. Okay, so yeah, good caps on the board now. It's still got the bullet going crazy, as you can see. So if I coin, and that gives me a credit. Now start. Ooh, it's working. Well, that's different. Alright, fire buttons still don't do anything. Well, actually, it did make my gun go down, so I don't know. Yeah, now this one does that one over there. Alright, yeah. Well, the controls don't seem to work right. Not that I don't think so anyway. So this thing does have issues. I don't see any planes flying around. Okay. You know what I kind of want to do is get my logic tester out and just test these chips, because there's a lot of off-brand junk on here that has been replaced, and it might be a good idea to just make sure that the stuff that was replaced into here is actually good, right? So yeah, okay. Okay, remember this 107 that I had a red dot on because the signal looked like this, kinda? Well, I had clipped these legs both out of circuit and probed the outputs after doing so, and they looked completely normal. So I knew that this chip is actually connected to this 7410 right here, and I clipped that leg, if you can see, sorry, right here, I clipped that where this came over. I clipped that, and if I probe this pin, which is no longer connected to anything, and I look at the scope, that's what it looks like. And this is what this now looks like. That 107. This is Q and then not Q, you know, so it looks normal. This 10 is the bad chip. That one right there. And since I clipped that, now I've lost sync. So, yeah, I need to replace the 10. Okay, I replaced that 10. And if we look at that 107's outputs now, they look exactly the same way that they did. Yeah, it looks exactly the same. Why does it look exactly the same? And it's still goofy. Now we have an airplane in the middle. We got bullets going up. Something with that circuit. I'm going to have to get the schematic out and look at the circuit and see what's going on. So, yeah, let me do that. Let me just study the schematic, find out what is this circuit, what's going on here, because that's just not right. That's not a valid TTL signal. So something is happening here, and I don't know what yet, but we'll figure it out. Okay, there's a 04 right here. And I noticed that signal, is that still doing that? No. I bet you I can put the 10 back in now. And the 10 is probably, yeah, still good. Hey, now we've got a plane flying. See if we can set this properly. There we go. So we've got a plane flying. But this 04 that was in here, let's just probe the inputs. Here's an input. The output should float. And it does, pretty much. Input. And this is the output. This is the output to that. See, here's an input. And the output is floating. Now if we go back up to this one, the input is actually floating, but the output is not floating. This is a 04. Input, output is low, which that don't seem right. Input, float, that's an output. I'm starting to wonder if this is the wrong chip. In and out, in and out. I think this is not supposed to be a 04, because let's let's act as if this is a 08. Here's an input, low, an input, and then the output floating. Okay, next one, input, input, floating. Over here on this side, input, input, output, floating, and input, input, floating. I think this is the wrong chip. This is a 04. Yeah. So I'm going to have to find out what that's supposed to be. It's probably supposed to be a 08, maybe a 32, a 00 maybe, something like that. So let me figure out what's supposed to be in here. That is at H. 789 H9. I'm going to look that up in the schematic. Okay, here is the schematic. Zero zero. That is supposed to be a 00. So let's put a 00 in that spot and see what happens. Okay, 00. And now, oh, look at that. Much better. And I want to put this on 2-player. So that I can test both 2-player, you know, player 1 and player 2. And just out of curiosity now, let's look at this again. Yeah, see now, that's not being held down now. So this chip that I replaced wasn't actually bad. It was being corrupted by that 04 that was up here. The 04 was driving an output that was corrupting another signal line. Yeah, so yeah. So there you go. All right. So now all we have to do is try it out. So let me, I don't want to burn that. Let's try coining up. Okay. Boom, we've coined up. We've got a credit and start. Huh. I don't know if that's how that's supposed to do that. I don't think that sound is correct. I think there's something up with the sound. Obviously, that doesn't sound right. It's credit again. Oh, it says it's got a credit. So let's just hit start. Oh, sorry. Yeah, I'm going to have to mess around with this off camera because I can't really concentrate on filming and doing that. So I don't know if this is supposed to just continuously shoot bullets or if it's only supposed to shoot when you push the angle button. There's 3 angle buttons. There's angle down, middle, and up on those. And I don't know if it's only supposed to shoot when you push the angle button. I don't know that. So I need to... what I'm going to do is YouTube some videos on this game and just kind of see how it plays. Because right now I don't really know what it's supposed to do. I know those sounds aren't right. There's some 9602 chips down here. And those are basically the sound chips. And they could be bad. We'll figure that out. I'm not so worried about sound right now. I want to get it playing correctly. So that's number one, is get this thing playing right. But I first need to know how it's supposed to play. So I want to see some video on this thing. So I'll do that and then continue. Okay, getting back to anti-aircraft. We're looking at the buttons. Remember, it just fires all the time. And I now see why that is. These are the fire buttons right here. Switch, 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 switch. And you see they are normally closed. See, it's the normally closed connection. So that is normally pulled to ground. And when you push the button, it releases that and it goes high. See, it's pulled through that resistor to 5 volts. And that's how this operates. So it operates in reverse. So, yeah. So I don't really want to use 6 micro switches in this. I have I have to just tie each one of these to ground. Because they're active when they are released from ground. So I got to figure out how I'm going to wire these up so that I can actually test this thing properly. So, all right, yeah, let me figure that out. Okay, here's what I came up with. This will go on like this, and this comes out to this dip switch. And you can see I got one side bussed together and then grounded through that wire. And then the 6 inputs are on the other side. And right now, they are all connected over to ground. And to activate the switch, all I have to do is move the switch off of ground. So this is right side down from right to left. From 1 to 6, they go right side down, right side mid, right side up. And then left side down, left side mid, left side up. So that's what I came up with. It'll work. All right, let's hook it back up. All right, so we're hooked back up and we're turned on. And this is normal, by the way. This just random firing when you fire it up. When you start the thing up, that's what it does. So let's coin up, hit start, and see if it waits to fire. So here's coin and start. Huh. Yeah, it's still doing whatever it wants to do. Huh. Yeah. Let me think about this. Do I have this thing wired properly in the first place? Let me check a few things out. Okay, I figured it out. This is a weird dip switch. And this is why I wanted to use this one, because I don't think I'll ever use this. These are not all active the same way. You see where the dot is? Like 1, the dot is on the top, 2, the dot is on the bottom. That's when they're active. So right now, these are all towards ground. They're all turned on and they're grounded. So now when I coin up, we shouldn't shoot at all. So let's go coin. There, now we're not shooting. And the only time it should shoot is when I move one of these off of the dot. And then it'll correspond to whatever that is. Like 1 is, if you look at it from this way, it kind of correlates from the right side of the screen to the left side, going from down, mid, up. So I'm going to mess around with this thing. I think this is now good. Yeah, let's go ahead and I'll just hook up to the tripod and I'll kind of explain what I'm doing, and then we'll see the actual thing shoot. Okay. And I turned the pot that controls the play time, so hopefully it doesn't end so soon. So I'll go ahead and coin up and start. Okay, this should be right gun down. There we go. Now right gun middle. And right gun up. Okay. Now here's left gun down. Left gun middle. And left gun up. Okay, so all those controls work. That's good. Now we just have to deal with the sounds. And it sounds like the sound for firing works okay. Yeah, notice now the playtime is way longer. I turned it all the way as long as it'll go. And there you go. So, yeah, we got to mess with the sounds a little bit. It sounds like the fire sound is okay, but the other sounds are not. So, and that could, these things right here are the sound generators. These 9602s, and I could just replace all 3 of them. You know what, I think that's what I'll do, is I'll just go ahead and replace all 3 of these 9602s. There's only 3 of them, and that'll probably fix all of the sounds. So, unless it's an amp issue, which I don't think. There's only 1 amp, right? I don't know. Let me see. Maybe we have 2 amps. I don't know. Let me check things out. But chances are I'm probably just going to end up replacing these 3 sound generator chips. Okay, back at the schematic. And you see here it says missile whistle. And that's a 566 function generator. And thankfully, the missile whistle is what I believe is good. So, that's very good. Here we have some explosion stuff. Target hit. See, this circuit right here has an op amp. And I noticed now that sounds kind of tinny and just not good. And that's an op amp. 747 is an op amp. So that's my suspect right there. 747. There's the main amp, 380. Yeah, this is going to be my suspect right here, the 747. I don't know if it's anywhere else. 747, I think, is I think it's just a dual amp. It looks like it's a dual amp, not a quad amp. So, see, 1, 2, 3, 4, 5. Yeah, 1, 2, 3. 1, 2, 3. 2, 3, 4, 5. Yeah. It's 5 pins per. It's a dual amp. It's not a quad amp. So yeah, and I do believe I have those. I'm pretty sure I do. Yeah. So let's replace that and see what we get. Went ahead and took the opportunity to hot glue my harness for anti-aircraft to protect from breakage in the future. And this. And to protect from shorting and stuff like that. So. Alright, yeah, let's I got that chip replaced. So let's hook this thing back up and see what happens. Okay, we're back together, and I had to replace that other dip switch because one of the wires broke after I had it glued, and I couldn't really easily just get it, so I put a new one on, and these ones all work in the same direction, so I like that better anyway. And we're on right now, and I'll fire the right gun. So fire sounds good. I need to fire up. I don't know. I'm just going to turn them all on. Actually, let me set this up here. The sound, basically, long story short, the sound is still not right. So, go ahead and do a little shooting. Come on. Yeah, kind of hard to play. It's just not trying to get high scores here. I'm just trying to hear everything. So the missile sound is good. The explosion sounds are not right. So we have explosions and they're not right. So I think my original plan of replacing these, I think I'm going to just replace all of these 9602s, and that will probably take care of it. We'll see. Okay, I replaced those, and it's the same thing. Yeah, see? Same exact sound issue. So it was not these. As a matter of fact, I think these are more involved in the position of the gun than anything else. So I'm going to have to rethink what I got going on here as far as those sounds and how they're generated. I'm going to actually have to look at the schematic. So let me do that. Look at the schematic. Kind of figure out these sounds and how they are generated. I know I know this amp was part of it, and I replaced the amp, and that didn't fix it. So what about transistors? Do we have funky transistors in the circuit? That is a possibility. So we'll go ahead and figure it out. All right, I found this anti-aircraft game on YouTube, and I want to go ahead and play this, and it's the same sounds as mine pretty much. This one is missing the distant explosion sound. Yeah, so that's the way this one sounds. And it sounds pretty much just like ours. I'm going to change and put an 8 ohm speaker on our board over there and play it again. Okay, go ahead and fire it up. Do a little playing. Alright, I think we might have an issue with the distant explosion sound. So I want to look into the distant explosion sound circuit. And I think it's just, I don't know, I'm going to have to look at the schematic. Okay, so I've made a discovery. These are all of the 0.1 microfarad caps that were in the board. There's a lot in the sound section up here. Plus they were, you know, the decoupling caps. And there was one over here. And, you know, a couple just around. Lots of them though. Lots of them up here coupling and actually working as signal pass capacitors. Okay. I decided to go ahead and remove all of these green ones because I've seen with this particular brand issues before. And as you can see now, if I take and I clip to one of these, I'll give you a view of what it does. And let me clip this. Okay. Now I'm clipped onto this capacitor. And what this device that I have here will do is it'll charge the capacitor, and as it gets to a full charge, the light will go out. What a capacitor does, let's talk about capacitors for a minute. Capacitors block direct current, but they will pass alternating current. Once you put, if you apply direct current to a capacitor, it will charge to a point, and when it gets fully charged, it will no longer pass direct current. Now, how it works with alternating current is it'll charge up, and as the current that you put on it alternates and goes up and down, the capacitor's charge will discharge, and it will charge up and down with the signal that's put to it. So it almost like a capacitor magically transfers current to the other side. It doesn't technically, in a what's the word, physics level, actually pass the current. The current kind of radiates from one side of the capacitor to the other, if that makes any sense. But with direct current, it'll just charge to a point and then stop charging, and no more current will pass, meaning no current will be transferred to the other side of the capacitor. And as you can see right here, current is just passing right through this cap. The light is still on. This is a good 0.1 microfarad cap, and you'll see what a good microfarad, a good capacitor will do. I'm going to have to put the phone down to hook this up. Give me a second. Okay. And there's a good cap, and you can see that the light extinguishes. Now what I'll do is I'll just touch my thumb to the leads and it'll light back up. See that? Now I remove and it'll charge until it reaches full charge and the light will go out. That's what a capacitor is supposed to look like. These are all bad. So I think these ones will probably be okay. The brown ones don't ever seem to be bad, and I know these are good. These, I don't know, but these don't really fail much. So right now I'm not going to check these ones. I will pull this big, just one of these out to spot check it, and then I'm moving on. I'm going to replace all of the 0.1 microfarad caps in this board. Yeah, I removed one of these big orange ones, and this one, it's a bigger, physically bigger capacitor, but it's a much smaller capacitance, you know, to the power of 10 basically. It's a 0.01, and right now you can see the LED is out, But if I just, all you got to do is touch your your skin between the two leads, and it'll light back up, and then remove it, and it goes out quickly. So as I suspected, the brown caps are usually good. It's these green caps that are terrible. Always bad. And yeah, these bad caps, if you put them on a capacitor checker, 101 nanofarad. And these are 100 nanofarad caps. 0.1 microfarads equals 100 nanofarads. So they test right on. But as you could see in the leakage test, they fail. So there you go. Capacitor lesson. Okay, I've replaced all of those caps. I even replaced the amp. And the sound is still the same. Yeah, so I'm just going to think that that's the way it's supposed to sound, because I can't find anything else wrong with this thing. There's nothing else wrong with it. So, and it's pretty close to what I seen on TV on the YouTube video that I watched. So I'm just going to consider that to be the way it sounds. I don't know enough about this. I've never played it other than this. So yeah. So I replaced a handful of parts on this thing anyway. Remember, it had the wrong chip in it altogether. I've replaced all of those caps. Replaced all the electrolytic caps that needed to be replaced. Replaced these three guys. And other than that, I don't quite remember. I set the voltage. I adjusted the voltage. Yeah, so anyway, there you go. I even tried a different 747 amp. I tried a different 4001. Yeah, just no difference anywhere. So I'm going to call it good. It plays good. All right, guys. Well, thanks for watching, and we'll see you on the next Classic Arcade Repair. Bye for now.